The 2 kilogram pendulum bob moves in the vertical plane with a velocity of 8 meters per second when theta is equal to 0. Determine the tension in the cord at the instant the bob reaches theta equals 30 degrees and neglect the size of the bob. Okay, so this is clearly a normal and tangential force equation of motion with AT pointing this way and A normal is pointing to the positive normal direction. We only have two forces, the weight, which is vertical down, and this is also theta, as you can see from this triangle. This is theta, and this is also theta. And we have the tension, which is towards the positive normal direction. It is just along the cable. So by taking the summation of forces tangential coordinate with positive up, then we have this component of the weight, which is 2 times 9.81 cosine theta, and this is negative, equals to ma times t, and this gives us the tangential acceleration as function of theta. In the normal acceleration, we have the summation of forces as follows. We have the tension along the normal, and we have this component of the weight, which is also positive sign, and this is equal to ma times n, or mv squared over rho, and rho is 2 meters. So to find the tension, we need to find theta and v. Theta is given at 30 degrees, so we need to find the velocity when theta is equal to 30 degrees. And since we have the initial and final angles, we can take advantage of AT, which is a function of theta, by having v dv equals AT times ds, where ds is equal to r d theta, or 2 d theta in this problem. So by integrating both sides and taking care of the initial conditions, which are a velocity of 8 meters per second when theta is equal to 0. And after 30 degrees, what is the value of v? So v here is our only unknown, and by solving for v, or v squared as seen here, we'll find it to be 44.38, and by using this v squared in the normal equation, we can see that v squared is the only unknown here, with theta known. So by doing that, we will find the tension in the cord, which is 34.6 newtons.